Want to be a trillionaire? Scientists reveal what it would take to mine an asteroid and say it could result in untold wealth. With all these recent close calls with asteroids passing the Earth, it comes as no surprise that many of these fast-moving objects could be a source of precious metals. There are many types of asteroids roaming the solar system, and many of these are made up of rocks and ice, while a good number of the remaining asteroids are loaded with metals. Some of these metals are rare and could bring a very high price if mined and returned to Earth. To be specific, there are some 12,000 asteroids of the type which could be mined for gold and platinum, as well as possible large diamonds within some 28 million miles of Earth. Now that is exciting many new space research firms that now have plans to send robotic craft to asteroids like this and determine the best ways to extract these metals. A metallic asteroid some 3,000 feet in diameter may contain at least $5.4 trillion worth of platinum. The problem would be how to extract and transport the final product back to Earth. Someone stands to become the first trillionaire. Asteroid mining is moving from the realm of science fiction to science and business reality. In theory, the business case speaks for itself. The incredible expense of space missions would be more than compensated for. But how do you actually go about mining an asteroid? How do you pick one to mine? Asteroids can be categorized as being made of carbon, silicon, or metal. Mining companies are particularly interested in metallic asteroids, but their compositions are still not well understood. NASA is fast-tracking a plan to explore asteroid 16 Psyche, which may contain the astronomical worth of $10,000 quadrillion of material worth. The mission, first slated to be sent to the asteroid in 2023, but may be delayed till 2026, will identify the true composition of the asteroid and possibly return some samples to Earth for further analysis. A mission to Psyche will help scientists explore a core of a possible former planet, as if we were to drill a core into Earth 1,800 miles deep. Telescope observations have been carried out, along with analysis of meteorites, fragments of asteroids that have fallen to Earth, and the data suggests that a small percentage of asteroids contain high concentrations of valuable metals, such as platinum and gold. So before we get swept up in how to spend our trillions, we must first prospect for suitable asteroid mining targets. More than 750 asteroids have been identified to date. The vast majority can be ruled out instantly, as they are found in the main asteroid belt, orbiting between Mars and Jupiter, too far away to be considered as potential mining targets. Instead, we should focus on asteroids near the Earth, which narrows the search to 17,000 targets. To narrow it further requires satellite observations with a telescope and spectrographic instrumentation. A spectrograph analyzes the sunlight reflected from the surface of an asteroid by breaking it down according to wavelength. This enables us to determine the composition of the surface. For instance, if the light from an asteroid appears reddish in color, this suggests the presence of clusters of iron and nickel on the surface. Platinum is normally found in such clusters on Earth, so we can infer that it might be present in these asteroids. However, we are only able to observe how light interacts with the surface of the asteroid, not the layers beneath it. And the surface may have been altered by collisions with other solar system objects or by exposure to radiation. When choosing an asteroid, we must figure out whether it is sufficiently large and whether it has a high enough concentration of valuable and highly used metal. Is it moving too fast? How far is it orbiting, and how long will it take to send a probe? According to Professor Martin Elvis, an astrophysicist at Harvard University, an asteroid worth mining needs to have a market value of $1 billion. In order to satisfy this requirement, the asteroid must be more than 1 kilometer in diameter, contain more than 10 parts per million of platinum, and have a velocity relative to the speed of the Earth of less than 5.4 meters per second. There are more than 17,000 near-Earth asteroids, but how many of them fit the bill? Professor Elvis made a theoretical estimation based on probabilities and assumptions. For instance, of all the meteorites that have fallen to Earth, approximately 4% were metallic, so we can assume that 4% of near-Earth asteroids are also metallic. Taking into account this and other probabilities, we are left with only 10 asteroids that are, theoretically, economically worthwhile and practically feasible to mine. As the targets have not yet been directly identified, the task now is to find these needles in the haystack. There is currently concern over the legal ramifications of this burgeoning industry, given the lack of laws and regulations to govern the international nature of space exploration. The United Nations oversees the Outer Space Treaty, signed by 106 countries. This provides a framework for the governance of space-based activities, but it does not provide the detailed legislation needed. There are concerns that the situation could become the new Wild West, with a lack of laws leading to disputes over who has the right to mine a particular asteroid. The first people to create the technology for mining asteroids will be rewarded with riches unlike anything ever seen. While it once would have sounded like an unrealistic dream, there are already a number of private companies hoping to cash in on the asteroid mining boom. What do you think? We'd like to hear your opinion in the comments. Don't forget to subscribe to our channel and turn on post notifications. There's lots of fascinating stuff ahead.